Hello, welcome, thanks for coming. This talk it only starts with a container. I'm Patrik, I work for Payara on their cloud runtime. And what we will be speaking about today is how this happens. As in, what happens after you just build your container, because from development point of view, it all looks simple, yeah? It's a method in a class that you put in a jar with your runtime, whatever you might be using. And yeah, put it in a container next to a JVM and the operating system base. And as I was preparing this presentation, and I started with those titles for the slides, and I went like, oh, this reads like a poem. So yeah, let's do a poem about a deployment. Yeah, I'm an endpoint, a method, and a class, sealed in a jar next to my runtime, shipped in the container inside a pod, within the namespace. Deployment keeps me scheduled on the nodes of wider cluster. Exposed by a service, adjusted with a config map, my secrets are a secret, and through ingress I reach out. One controller guides my packets, another gives me name, yet another proves me valid, and there's more of us, but we're not the same. You hear me in network calls, you see me in logs and metrics, you know me through past selves, all the versions, remembered settings, layer on layer, object by object, abstraction becomes reality. And there goes 5 hours in PowerPoint. However, thank you. However, this brings us to an interesting point, like abstraction becomes reality. All those things are really abstract. So what an abstraction means in this context? It is leaving out details, so they are filled either by convention or it can be inferred in some way. And Kubernetes itself, it's still pretty abstract. You create your resources, dozens of processes will kick in, reading the changes of in that data model in etcd and start making real things on real machines. But ultimately, there is still, there's a different levels of abstraction that we are speaking of. So on the one hand side, we got a poem as really, we can probably all agree, really high level abstraction. And we now start building from the bottom up. So on the opposite side of spectrum, we have another language with word indentation, and that will be YAML. So how do we do this poem in YAML? It looks something like this. The individual contents are not that important. However, you get to name all of your resource types, give them names, give them matching labels, your container image, and so on. And if you are deploying a Java application, you are not deploying probably this single application. You'll end up with lots of applications that differ in very small way. Yeah, not usually just different code base and different configuration, and maybe some different place where they are available. So if we create a second application that's just like that, you'll see it structurally, it looks pretty the same. However, there are lots of differences. So I went and counted them, and that ended up being 14 lines changed. Yeah, this is still a very simple descriptor, just the deployment service and ingress and a config map. And there is quite lots of repetition. Yeah, it's mostly about, the instance name is different. This isn't really abstract. Yeah, there's probably a convention how we are labeling our things once we know what the application name is. So we need to seek like higher level abstraction. And what will that be? The simplest one you can have is shipped with your kubectl client, and it's called customize. And it has predefined set of transformation it can do onto your files. And in addition to that, it can do arbitrary patch operations. What you'll end up with, usually you've got some base set of resources that describe in generic terms what you want to deploy. And then you'll have these transformations described in another directory, and those are referred to as overlays. So an example of such base configuration file would be this, where you got just list resources, deploy everything that is written on those YAML files, and that's it. And then your overlay will refer to this base file, like, yeah, do everything what they say, but put it in different namespace. But give a name prefix to everything we create, and change the labels. And then also generate config map for a file. Yeah, this is the thing that gets a little bit upsetting when you're doing YAML by hand, that you need to put everything inside a text block in the YAML file. So this helps you with that. So ultimately, we now describe two instances by just describing what the changes are. Oh, and the ingress, yeah, where this should be, and there's no predefined transformation for that. So you'll end up having an actual patch, like, okay, the place when we describe ingress, replace something on this path for me. So in the spec, first rule, change the host to this thing. So it gets quite structurally bound to what your source is. And ironically, even though we only describe the differences, this turns out to be 23 lines, so even more than before. So it didn't really help with minifying the information to just say, like, what is the difference. Another example would be when I not only want a different host name, but I also want different context root. Yeah, so the application should be available at another base path under the domain, and there you really see how this becomes dependent on your base. So we know that we need to change first path of the first rule to something else, and then for our application, this sample works that way that it happens to be fourth argument on the command line. And then, yeah, the moment you change base and you decide to add a JVM argument, this stops working because you replace something else. For many kinds of situations, you get this locality problem that your one desired setting ends up being at different places. So as your memory reservation goes up, you may also raise the max RAM percentage parameter to JVM. So you know that I don't need that much of heap memory when I've got 12 gigs of memory available. Or when your CPU requests are low, but they are burstable, you may want to adjust active processor count. So one thing at two different places. And this is where customize will not help you much, because it has this strong dependency on the structure, and it doesn't really have any higher order components, like, yeah, give me two variations of this file at the same time. You cannot even make this kind of customization that will combine one thing with different transformations in a single go. And also, it's not pleasure to work with. Yeah, the documentation isn't really clear, and almost no features are being added to the tool. And if you're working with plain YAML and you've got a problem and the API server will say no, then you need to figure out what to do next, because there's no clear rollback path. So we probably want something better. And what we usually end up with is templating. So the list of the templating tools is probably really short. Who uses Helm here? Yeah, who really likes Helm? Not much enthusiasm there. It's a templating tool, but I think the more important thing that Helm gave us is the distribution path. Suddenly we have Helm repositories, or we can put Helm charts in the OCI repositories, and that really helped the adoption of Helm. And it also helped many projects being able to distribute their project to be deployed in a Kubernetes. But there are different ones. There's JSONet, which is a nice configuration language. It has inheritance, it has classes, it has way to do computation in a really nice way, and it can produce JSON. And if you wonder why that is relevant, there's a secret for you. Every JSON file is a YAML file. So you may utilize that if your YAML gets too unwieldy. You can just do parts in YAML. Parts of the YAML in JSON and still use comments, for example. So there's a tip for you. And there's this one new project I spotted recently called YAML. They aim to do the delivery pipeline in a way that you specify your parameters, and your program is anything in WebAssembly. So you pass the parameters to a WebAssembly program, and it should spit out YAML or JSON. So it's an interesting thing to try. Now that you can compile Java into WebAssembly, and then use this instead of Helm, maybe. I don't know, I didn't try. But yeah, might be something interesting to look at. However, back to Helm, because Helm will be what you will be using. So for those that didn't raise their hands that use Helm, it's the structure, the thing we distribute with Helm is called a chart. And it is consisting of few files. There's metadata in the chart YAML. Then values YAML is just a structure that serves as a configuration. And your actual resources to be generated are under templates. And yeah, they generate YAML, which gets applied then. If you create a Helm application with a standard Helm create container app, you will get lots of values that will be describing still on quite on a low level what your services should look like, what your ingress should look like. But you can mix and match. You can set some of those in stone so it doesn't need to move. And you can get to pretty neat templates. For example, here we've got our definition of ingress. So when we get back to our locality problem, how do we now make the ingress setting equal to what we say in the deployment on the command line? We have ways of doing that by means of not so beautiful templating language Helm comes with. We can say, all right, it's a first host and the first path of the ingress. And yeah, it's kind of trouble that Go templating is more considered with uniformity than with ease of use. So many times you'll end up with quite complicated expressions. My favorite gripe would be like, until a few years ago, the end function will not be short-circuiting. So it would always evaluate both expressions in end. So we couldn't really do like a null check. But that changed 2 years ago, maybe, after 3-year-long discussion. However, we now have a templating language that we can use to construct everything. And we can have multiple instances of the same chart. So even if our applications don't differ much, if we can cover everything in the values, that's your guy. Yeah, Helm's your guy for that. You can even reuse, you can create composite charts, which is a bit of an edge case, but it happened to work. So you can depend on the same base chart, which is called container app here, and using aliases to tell two dependencies apart, and then configure both of them in a single value file in 20 lines. If that's the metric we are after, then yes, we can definitely improve the level of abstraction there. But there are limitations. Values cannot be interpolated by default. You will need to you need to include that in the chart. You need to use the TPL function to actually try to interpret the value if it will refer to any other value, for example. So it specifically needs to be supported by the chart, which isn't great if you are not owner of the chart. If you are trying to customize something third-party, I don't know, traffic or something. The way we solve that problem is that you build a check. In your top template, you just do like, if this value and this other value is different, then fail, explaining that yes, these need to be equal. That's the only workaround we found so far. And another limitation is that there is a global namespace for templates. So if you've got two templates, both, if you are using two subcharts, both using the same template, it will be an error if they define the same template. But Helm will get you really, really far in the deployment story, especially if you then plug in something that deploys them automatically. There are two tools for that. One will be ArgoCD, the other will be FluxCD, and we can shortly look on what you get with Argo. So you will have like a list of applications. Those are all the examples I showed. So like from plain YAML or from Helm. So I don't know, let's do customize first. It could be polling. It will be polling your Git repository, and whenever there is a change, it will either apply that automatically or apply that manually. Now we are going for manual synchronization. And here you will see a list of, yeah, this is my customized definitions, and then it will be creating like a three overlays of the same base. And yeah, we can then access, I don't know, third instance right here. You get a click, and yeah, and it will fail because probably I had a typo there. But yeah, let's see the plain YAML. Plain YAML will never let me down. So we've got the endpoints here. Come on. Yeah, okay. Now we're there, or we can use the second instance of the thing. And the point is, you get a nice way of seeing what is deployed, what is the state. It will keep its own history of when it applied something. It will give you ways to roll back if you want to go back, and single sign-on permissions, everything. So this combined with Helm is probably the usual answer. However, the problem is, yeah, we still are kind of far away. Yeah, we end up with this kind of polyglot deployment. We do our thing in Java, then we do our Kubernetes things, then we fight with Go templates, then we define an ArgoCD project, and then we put it together with even more YAML. So while we abstracted the commonalities away, we are far away from where we wanted to be. We wanted to deploy an application, and we still didn't touch the rest of the things, yeah? Things beyond Kubernetes cluster. You might want a database, you need special roles for your application, and so on. So what if we could define our state in the program and anything other we need in some kind of program where it could be then applied to our target cluster? So the obvious choice will be Terraform. However, the thing I like to speak about is Pulumi. Has anybody heard of Pulumi here? Very few people. Pulumi is as an open source project, or also a service that allows you to write your application not in the form of a Terraform configuration file, but in any general purpose language, or any, where if it allows you to do Java, TypeScript, Python, Go, and I think those 4 are supported. And the program is executed. During its run, it creates resources and their configuration, and that thing then gets reconciled with the state of your cluster. The way it is done, it's mostly it will speak to the Terraform providers, but you've got much better programming model. You've got entirety of your programming language at your disposal. So if you want to create a namespace, for example, you just do new namespace, and the namespace will be created. And for things like the specific, my special kind of Java application I want to be deployed to Kubernetes, you just create a class, and that class will have really few parameters. Yeah, it will have the name, the host name it needs to be on, and the context root, and you can tuck away the details further down. And even so, you've got ways of configure it directly within Pulumi. You can now think, I can use anything as a data source. You know, I can read a CSV file on my file system. I can reach to external service or whatever to find like what is the infrastructure I want. So this really moves your abstraction level way up. As far as that and also dependencies between values become apparent because they will become method calls and they will be constructed together. As for how this thing is implemented internally, well, it's not that nice because there are like lots of builders. But yeah, I really invite you to try that out if that will work for you. All right, and yeah, you get additional bonus features with that, yeah, because it can keep all of your supporting infrastructure up to date. It can handle Kubernetes version upgrades well, or yeah, add managed databases and identities. So yeah, I would say that's definitely higher level of abstraction in terms of how can you describe what you need and yeah, what you get back. Fine, but is that what we want? This is what our life is supposed to be. When we just want to be running our application, and yeah, that's why we were looking for a solution for that, which is called PyaraCube, and it's kind of manage automated cloud native runtime. So you just put us your you pass it your application binaries, which can be either a Jakarta EE application, because we are still proudly making a Jakarta EE application server, or a Spring Boot or Quarkus application, and then the minimal configuration you need. Yeah, any application properties, what JDK you want to run, and so on. And it's kind of pre-configured Kubernetes cluster, and anything around it that will make it run. Yeah, and you'll get like the endpoint to connect, the metrics, and logs, and threads and heap dumps. So I'll show you a little bit of that, because there is it's kind of similar to those endpoints, and it looks like this. So yeah, I've got multiple namespaces. Each one has a host name associated with that, and within the namespace, I get multiple applications on different paths, and some metrics with regards of what the memory usage was, the number of HTTP requests it got, and log entries that were generated. And yeah, it can do all of them. So yeah, we've got all pet clinics of the world here. Yeah, we've got Quarkus pet clinic, Jakarta pet clinic, and Spring Boot pet clinic. So yeah, all of these frameworks are supported, and then for individual application, you can get like basic metrics, or you can get a thread dump of a running application, and it gets downloaded. Yeah, and you can go and inspect it, and you have also ability to monitor like the basic behavior of the application, like looking at the logs. This usually also, since you are doing some kind of pipelines, that will require running that in the pipeline, and for that, we have a CLI. When you say like, okay, I've got this WAR file, upload that for me. It's not deploying automatically because you might want to configure stuff yet. And yeah, show me logs as it's deploying. And this is how it works. Internally, what it does is that we will have kind of a Kubernetes controller written specifically for each kind of applications. So it will fetch just those basic data. So what to deploy, what is the CPU reservation, what is the configuration, and it will apply, it will create those resources directly in the target cluster. It can run with multiple clusters as well. Okay. I might be going seriously ahead of myself. So, are there any questions at this point that I could answer? No. Well, at this point, I will just conclude with the fact that if you have many similar applications, you might be looking for a sufficient level of abstractions, and this is something we built that you can try out. This link, don't be scared by the buy. It leads you to a trial, or there is like general information about Kube on that first link. The source code for all those YAML files I showed is available, but with the caveat that this is kind of works on my cluster thingy. So if you do that, you will need to do set up your ingress, set up your host names in the way that it will work for you, but it shows the structure you usually end up with. Right, unless there are no questions, then that's all I have. So are there any? Yes, please.
Have you heard about open application model?
Mm-hmm.
Because it's what you said, it's a little bit similar with open.
Okay, so it's similar to open application model. I will need to look that up, unfortunately. Yeah. Anybody? If not, then I thank you very much.